All right, so a complex number is a combination of a real number and imaginary number. So any number can be written as a complex number. It's composed of a real part. So a plus bi is kind of the general way that we write it. A would be the real part, and then b times I would be the imaginary part. So examples of complex numbers, 7 plus 2i, 7 is the real part, 2i is the imaginary, 4 minus 2i, 4 is the real, negative 2i is the imaginary. 3 is considered a complex number because you can actually rewrite it as 3 plus 0i, so the imaginary part is just 0. And same thing with 7i. The real part would be 0, and the imaginary part would be 7i. So we can do operations with complex numbers just like we did with polynomials. We're basically just going to add and subtract like terms. So looking at number 1, the real parts we can combine together. So the 2 and the 7 make 9. And then we can add together our imaginary parts. 3i and negative 6i gives me negative 3i. So simplified down, this would be 9 minus 3i. When we're subtracting, we do essentially the same thing we did when we did with polynomials. First thing we're going to do is we're going to distribute that negative. So we're left with 4 minus 3i. And then remember, we switch the signs of everything inside the parentheses. Minus 6 plus 8i. And then we combine our like terms. So for the real parts, we have 4 and negative 6, which is negative 2. And for our imaginary parts, we have negative 3i and 8i, which makes 5i. And then we can do the same thing when we multiply. So remember when we multiply, there's two methods we used. So I'm going to show one using the box method to multiply. These numbers go on the outside, so the real and imaginary parts. And we can actually multiply inside to get the inside. So starting with 7 times 2 is 14. 7 times 3i is 21i. 2 times negative 6 is negative 12i. And then 3i times negative 6i is negative 18i squared. Then we combine like terms. So we know that here across the diagonal are going to be our like terms. So my real part is 14. And then 21 and negative 12 gives me 9i. And then at the end we have negative 18i squared. Okay. However, in the previous lesson we learned that I squared is equal to negative 1. So really this becomes 14 plus 9i minus 18 times negative 1. So this whole thing turns into plus 18. So now we actually have another real part. 14 plus 18 is going to give us 32, I believe. Yeah, 32 plus 9i. So really what this I squared does is it actually switches the sign of the coefficient since we're going to be multiplying by negative 1. All right, looking at the second example, I'm going to do this using just the distributive property. So 4 times 6 is 24. 4 times negative 8i is negative 32i. Negative 3i times 6 is negative 18i. And then we have negative 3 times negative 8i. That's going to be plus 24i squared. And then combining like terms, 24, this is going to be minus 50i plus 24i squared. But we know that I squared is negative 1. So this is going to end up giving us minus 24. So our real parts are going to cancel out because 24 minus 24 is equal to 0. So we're just left with negative 50i.